AI is everywhere in education. I'm sure you guys see it right now. And I think we as educators are like, what do we do with this? This is a beast. And personally, I'm taking the long game on it, except for I'm nervous that it's going to reduce kids' ability to think critically.
Like DNA strands on a fascinating roller coaster of endless learning, experimentation, and discovery of technology, where the destination is not the end and the journey is the most fun. This is the Helical Brew. With your hosts, Mike, Sura, Jeff, and Elizabeth.
Welcome, everyone, to the Helical Brew on our new episode, our first episode of our Blueprints to Breakthroughs series with our first guest, James Fieberg, out of the San Diego area. Welcome, James. Thank you very much for joining us. James is a teacher, STEM educator, and I'm going to point it out, a San Diego County Teacher of the Year winner. So, yeah, very cool. And we are starting this Blueprints to Breakthroughs series with an educator, which I think is cool. The reason I'm wearing stripes, I'll just throw that out there, is the fact that later on today, I will be going over to a STEM program, First Robotics. I think for folks that know me, I've been involved in that for like 15 years. But anyway, that's why. So having a little fun with that this morning, and makes me even more excited to have the conversation we're going to have today with James. So welcome, James. Thanks for joining us.
Thank you. Yeah, thank you very much for having me. I'm excited to be here and learn from all of you and your experiences.
Yeah, so, education, being involved in FIRST has kind of opened my eyes, kind of, education in adulthood, right? As you have your memories as a child. I have mine of, going through high school, going through college. How did I even arrive on this? What were my inspirations? But, being involved in a program like FIRST has given me an opportunity to really reflect on where those impacts came from and the people that made a difference. And I have, there's no question an educator like yourself is impacting lives every single day, every hour, and connecting, because I remember those connections myself. So it's super important. So I was wondering, give us, tell us about you, James, and your passions and what brought you into that space. Yeah.
Yeah, well, again, thank you for having me. I'm excited about this. So this is my 27th year of teaching science and engineering. I'm currently in Carlsbad, California. Grew up in Chicago and wanted to go to med school, of all things. And so pursued kind of pre-med, and then was kind of sick of school. So I basically didn't want to go right away to med school, and was lifeguarding, and some kids that I was lifeguarding with said, hey, we need a teacher at our high school. And I needed a job after graduation. So for some reason, I applied and I got hired to teach, and that was 27 years ago. And so ever since then, I just kind of fell in love with the process of teaching. A couple years later, moved out to San Diego, and Carlsbad School District hired me up. And I've been basically teaching all levels of science. About 12 years ago, we opened a new high school in the city of Carlsbad called Sage Creek High School, and I was brought on to lead the science team. So as part of that, we had a curriculum called Project Lead the Way, which is a national STEM organization. Basically, their intent is to get more scientists, more biomedical engineers, computer scientists into American companies. Chevron is a huge supporter of it and put a lot of money. And now it's a huge organization. And so I teach, and I've been teaching for the past 8-9 years, I think, engineering. Okay. And so we have a 4-year pathway. The pathway of engineering is they do a design class first, then they do kind of an overview of mechanical engineering, and that's one of the courses I teach. And then we choose a computer science as their third course. And then their fourth course is called Engineering Design and Development. It's called Capstone right now, but that's my most favorite class, and we'll get into that in a little bit. But that's what I've basically been doing. So I also teach AP Physics currently right now. And my philosophy is a very inquiry-based one of inquiry, as I believe students need to be given challenges and given the tools and the freedom to explore. I'm not a type of teacher that is, I like to call a cookbook teacher, where I'll give you a recipe and I'll say, here's a set of instructions, follow these, and you're going to get exactly what I want if you do what I tell you. I'm a believer in, here's a challenge, here's a phenomenon, and let's go figure it out. And I do that both in the science education and also in engineering. I love to give them a problem, a real world scenario, and say, here's the equipment, go solve it, and let the kids just do what they want to do, and guide them, of course. I like to call it like bumper bowling. I'm the bumper, we're going down the lane kind of thing, but give them the
That's
freedom
awesome.
to go where they want to go and create. And I'll tell you, the kids just love it. I just had some people in from the County Office of Education, and the kind of theme was like, why wasn't this class when I was in high school? And I felt the same way.
I was just thinking that.
Yeah.
We just did a teaser for your episode, and Mike seriously was like, why wasn't this in place when we were going to school?
Oh, I wish.
I would totally be an engineer, I'm sure. I was excellent in math. I couldn't read to save my life, but nobody ever said, hey, engineering is a career path. And so as an athlete, I thought, the human body was cool, and I wanted to study it and get into medicine. So funny how life works,
Definitely.
That's, again, quick rundown of me and my career in a couple of minutes.
Yeah, that's awesome. I appreciate that. And do you feel like engineering? I feel a theme in what you're talking about and how you're presenting problem solving to kids is, do you feel like engineering is I mean, it's a field of study, but also kind of a framework for education in a way, because of that sort of here's a goal, you figure out how to get there. That's just engineering in general, when they, I remember I had a real hard time connecting in high school, and a lot of it was because what you just said, the sort of the menu, this is a fixed menu. We start here, we do all steps, and we end up here. And then engineering, well, by the end of your sophomore year, they start doing enjoy. Here's some people you need to talk with. So you need to figure out your social situation and connect with these folks, because they're going to help you get there. And we would work with AT&T and different telecom companies on how to make, devices, right? And they'd be like, okay, come back, write a report, come up with a binder, and to me, a lot of people I was in school with connected with that so much better. And what you described, I wish I was doing that in high school. That would have been awesome.
I'm a big believer in design thinking and kind of study the Stanford D School methodology of begin with empathy. And I think we just don't do that enough. We as teachers pump just curriculum because we've got to get through it. And, we need to make education relevant to students' lives. And again, that's the idea of starting with empathy. And it could be a history class. It could be a math class. Obviously, engineering lends itself so easy to that idea. And I think if we could get more of that in the education world, students would be 10 times better, in my opinion.
Yeah, and I think that's why I liked physics in high school, because I finally saw the application of the theory. And, you don't see that in anything else in high school, right? You don't see that centrifugal force come out like you do so prominently in physics. And that was really important to see that happen.
Yeah, it's one of the reasons I love teaching physics. It's real. You can touch it. Just yesterday we were doing a ring versus a disc, rolling down a ramp as a phenomenon, and just, which one wins, the disc versus the ring, same mass, same diameter. It's such a neat lesson. But the kids have never seen, okay, let's go play. Let's go figure out, why does the disc win the race rolling down a ramp? So yeah, you can see it, you can touch it. And that's what I love about teaching engineering and science, for that matter.
It sounds like you take the approach of, you will interact with these concepts on a daily basis, and let me show you where this is going to happen. I've coached VEX teams for quite a few years as well. Not like Mike, he's a referee. I've never done the refereeing. I'm more on the coaching side, but just it's sparking that curiosity. And I'm sure you can associate with those light bulb moments where you thought you just weren't getting through. And then all of a sudden it's like, they got it. Oh my gosh, they got it. I can't believe it. So yeah, it sounds like you want to use those practical applications that you're talking about empathetic association. It's like, See, this is where you can see it, you can feel it, you can touch it.
Yeah, I mean that's so that those connections to kids is the most important thing. And I mean, I've got two daughters, and one in middle school. So many times, just given a computer and just watch this video, fill out this worksheet. And, she comes back and there's zero excitement about it. That we can't be doing that to kids nowadays. And I think the more we can create these kind of courses, engineering, and that's just a framework, like you were saying, Mike, a couple minutes ago. Let's get that design thinking into a history class, into a math class, whatever science,
Sure.
whatever the case may be. I think that's so important.
Yeah, you bring it up. It's like history and all these other topics. They can all be put in that frame of mind when you think about it, right? Go hunt for the answer, go search, do your research. Sorry, Elizabeth. What were you
Yeah,
saying?
no, I was going to say, because I have two kids as well, and my son, he's 15, but they spent 2 years in Ecuador, and they were in a Montessori school, and such a difference it makes with education when the transition to come back to the regular education system was really tough. Unfortunately, here in Canada, there's not many options for that. But it does make such a difference when the kids actually get to touch and do their things and be creative. In the school there, they have natural reserve, and then they get to go and see the actual, the plants and do research on animals and insects and all the kinds of things that here, they don't get exposed to that. So teaching biology versus teaching something on the book is different.
Yeah, I think, and that's, something we can obviously chat about, but I think the real world connection is huge for kids too. And I think, one of the things that I've really tried to do over the course of the past few years is get kids into industry and see what just even, what does it look like, their desk, even what does a company's atmosphere look like? What does
Sure.
An engineer, a scientist do on a day-to-day basis? I've also created a mentorship program for my senior level engineering class. And I think that's important, just to get them out and get, like you were saying, Elizabeth, touching bugs. Like, how cool is that? Rather than seeing it on a video, for example. And I think that's important. And I think that's important for industry. And I think that's something we probably are going to talk about here. But how do we create more of those partnerships is very important.
Just as a quick question, do you feel, I know the San Diego County school districts have certain guidelines and curricula they throw at teachers. Do you ever feel like some of that stuff really constrains what you're trying to do? Because I think, my sister's a teacher and she's always trying to pack that in, right? Which I think really limits some of this out of the box thinking that maybe educators want to have.
Yeah, 100%. I think the bounds of curriculum are the curse. We try to standardize education, and in doing so, we somewhat tie the hands of creativity of teachers. And I think, the beauty of an engineering class, I have a curriculum, but if I don't do exactly what they say, there's no police, you know what I mean? Nobody's going to come after me.
You just outed yourself here.
Yeah, no, I've had principals and administration that says, hey, focus on what's the most important stuff. And if you miss a little bit, that's not the end of the world.
Oh,
This idea of, we have a kind of a philosophy of fail forward. As educators, don't be afraid to innovate and try something new. And if it flops, it flops. And if that comes at the expense of a little less curriculum for the kids, we have a philosophy of it's not the end of the world. So again, outing our school and whatnot, but yeah, we may not cover all of that. And I think a lot of teachers are fearful of not doing that at the expense of fun and creative, learner-centered projects for the kids.
But you also have that hierarchy that supports it, right? It has to come kind of from the top down to allow you that freedom.
Yeah, exactly. 100%.
That's good that you've got that support genuinely at the local level. Someone that you're going to interact with every day, because from a Department of Education, that's at a state house or in Sacramento or wherever, you're not going to interact with them. But it's the people who are, like Sura said, I've got your 6. Yeah, go for it. Challenge them and push your limits. Question as it relates to the kids, and you talked about don't be afraid to fail. Do you find the current generation of kids are more afraid to fail, or just charge ahead? If we fail, we've learned, and we're going to do it a different way. Same thing, but we're going to do something a little different to make it better. You find that's being the case?
Yeah, it's an interesting answer I'm going to give. I think grades are so important to kids, so they aren't afraid to fail as long as they get a good grade. And I think there's a fine balance between the two of those things where how do we allow kids the freedom and the flexibility to take a risk, to fail, but at the same time make it not penalizing, if that makes any sense. And luckily, kids who are signing up for AP Physics, engineering, are higher achieving kids as it is, and they're more supported at home. Generally speaking, they're more, of a higher academic where they can, I don't want to say recover, but they're more of the kids that are saying, yeah, I'll try it, and know that they have supports. And I think that's also just a culture that I've established in my class that, hey, you know what, this project that we build could fail, but what are we learning from it? If we have a design specification and you don't meet it, well, why didn't you meet it? Let's analyze that, because I think that's as important as anything. And I think if you can set up systems and structures of grading so that the reflection is as important as the answer or the correctness, then I think it provides kids the opportunity to fail, Jeff. And I think, fail is a loose word, but at the same time in AP Physics, a test is a test, and we're grading against standards. And so sometimes in those, you fail a test, But again, we come back and we look at why, just like in engineering.
How do we get here?
Did this product fail? What was the reasoning for it? And let's go back and try to, attempt number 2. That's it. Yeah.
Yeah, that's huge. I think, I took one kind of advanced level class in high school, and that was one of the big differences was the testing was way more critical, right? You're going to get credit for this after high school, and which makes sense, but at the same time, figure out how you got there. What do you need to do to fix it if you need to? Thought I'd segue into our first segments, specifically around the future of engineering education. Get your thoughts on that. From the outside looking in, every time I go to one of these high school events with FIRST, right? Each high school is set up a little bit differently. We often end up in, this time we're in the ROTC room, actually, where we are sort of our break room for all the volunteers. And anyway, you just sort of, look around and you're like, all the computers and all these tablets and things like that stuff. We didn't have anything close to that. Best we had was a TFT touchscreen, But and we'll get into some of the challenges with the technology and get your thoughts on those. But what do you feel the current trends are in STEM education in general? And their impact on innovating in the space.
I think robotics is the big one, and I think behind that is computer science education. I think there's a lot of buzz around coding and teaching kids to start to code from simple block coding all the way up to Python and C++ and stuff. But then again, I think it's easy for a company to put together a kit where a kid can build a robot in class. And I think a teacher can be given the instruction manual easily, and it's Legos. For lack of a better word, and kids can put together Legos. They figured it out a long time ago, the formula, and it's very similar. And so I think a lot of the trends, again, to wrap up one more time, is robotics and coding. And then, of course, 3D printing is kind of a cool little fun thing that people like to do just because it looks engineering. It looks like we're building, we're creating. And it is. It's easy to get. There's free, Onshape is free. SketchUp is free for the most part, I think. It's easy to get kids into a relatively inexpensive way of starting their engineering education.
Yeah, pretty cool. You can extrapolate your imagination now into a tangible thing without a tremendous amount of cost these days. That's pretty remarkable.
Yeah.
But I did see you also had your AI certification. Are you trying to do AI in the classrooms now? Because that is kind of the big buzzword.
Yeah, thank you for saying that. That's another big thing. AI is everywhere in education. I'm sure you guys see it right now. And I think we as educators are like, what do we do with this? This is a beast. And personally, I'm taking the long game on it, except for I'm nervous that it's going to reduce kids' ability to think critically. And I think, for example, I just in my my senior engineering class, they were writing testing plans to test against their design specifications. And a lot of them were using ChatGPT to come up with the testing plan. And it was like, okay, that's great, but is this any good? The critical thinking part is the procedure that you're going to follow value? Is it repeatable? Is it reliable? And we won't know that until we run this test, but I'm nervous that they're going to start to default way too much, which kids are. I mean, you walk around a classroom and ChatGPT is on every screen, and if we think it's not, it is. We're the idiots that don't think that.
Somewhere.
Yeah.
It is. And that's okay. So, if we're not going to beat it. We might as well embrace it then. And so that's where I'm taking the long game on it. But yeah, AI is huge, and there's so many companies that are trying to capture that. And how do we win the AI game with students? So I hope that answers that question.
Yeah, I think that's my worry is that, I didn't have ChatGPT growing up. So everything I had to, and I'm probably aging myself, like look in the encyclopedia or, talk to actual people in the field. So I feel like that level of critical thinking and just kind of even thinking about where to start is getting undercut by asking ChatGPT, hey, this is what I need to do. What do you think? You know what I mean? And that's kind of what I'm worried is how do we balance the availability of AI with the fact that we need these little humans to think critically for the massive problems they'll face in the future.
Yeah, 100%. And I think engineering is, again, lends it. I give my kid a project. They can't chat GPT how to build, we do this silly coffee cup lifting design. They can't chat GPT how to build that thing in my classroom, but again,
you'll end up with just some weird things.
It's hilarious. I do
the Chat GPT challenge. Ready, set, go.
But you know what?
You can come up with the best prompt. That's what it is.
Yeah, I'm glad at times I'm not an English teacher, but at the same time, I think there's going to definitely be a fine line between the benefits of something like that in education versus it just taking over. And kids are going to do. Jeff, you asked this question a couple of minutes ago, the failing, they're going to do, or and even on the, Mike, I think you were saying this, but they're going to push the limits to whatever they can. You say 6.5 inches, they're at 6.49999, because that's what kids do. So we did it too.
Yeah, I was going to say we did it too.
Yeah. I always use the aircraft analogy. It's like, well, do you want the pilot to use the minimum amount of power on takeoff or maybe a little more? It's like, and then they start going, yeah, okay, I'll make the cut a little bit longer next time, so we're not right at the limit.
Well, your concerns are not unwarranted, and we see them in our industries as well. From our end customers, I think the first big problem is they just don't even know what it is. Yeah, you can say Chat GPT, okay, I tell it something and it spits something out, but I don't think they really understand what artificial intelligence genuinely means. And I'll be honest, I don't either. And we've had a couple interviews before, then I've asked that question, and obviously they're not experts either, and they're like, well, I'm probably not the best person to ask, but yeah, I think it's not unwarranted. The long game is probably the best approach, but there is definitely a use for it when it comes to specific things. I've heard it said recently that it will kind of unleash the human creativity by taking over those mundane tasks, just like what automation is supposed to do for us and for our research colleagues. I think that's kind of the idea, but we'll see. Time will tell, right?
I believe that the most important part is guiding them towards using the tools properly and effectively as well. Because I had the same conversation with my aunt, which is the director of the school in Ecuador, about social media. And we were discussing, we cannot prohibit them to be in there, but we have to guide them how to use it well. And the same thing with AI and all these tools that are coming. We have to introduce them to them and guide them. So that's the role of the teacher at this moment. So big challenge for you.
I feel like the hype, part of every topic like that, there's a hype side, and then there's the kind of the behind the scenes side. And with AI, I feel like the hype part is the Chat GPT, the using it to write things, using it to create images. Is sort of like the analogy I thought of the other day was like, you have a pool, two ways to clean a pool. You can use one of those devices that goes all around all day long and concentrates something at the end, and that's what you get. That's sort of AI. And then I can just take a net and go pick the clump of leaves off the bottom of the pool as well, and that's sort of the human approach, more direct, but less diverse set of information. But there's a whole other side that we see especially in our industry, in life science, where I'm not in that space as far as doing the research, but we're supplying robotics and automation. They're trying to build the biggest data pool that they can use to make better decisions, and AI has had a lot of value there. But this is where the critical thinking comes in: how to use it strategically for a specific application. I think that's maybe a story for some of the folks that are growing up with this stuff to hear, is that, look, here's an application, you couldn't find all these proteins without it, right? It would be impossible. There's no amount of time where this science has existed that you could have done it, and the AI did it perfectly, or did it much better. But that's a great application. Then that's a tool that we can use as opposed to a crutch, But yeah, it's interesting though. I mean, there's some really, really great applications for it, that aren't the ones that are being talked about, I think, on a daily basis, just because of the it's like you said, the exposure thing. If you walked into a pharmaceutical company, you would probably hear these stories, if you're talking to their automation folks. But yeah, no, it's more to come on that one.
It always comes up in the podcast.
That's right. AI and the future of laboratory automation. Those are two that we
on our next series.
If we're all replaced with avatars, the show's done. That's it.
Yeah. Great discussion. Just going to switch gears a little bit to talking about essential skills for future innovators, and kind of, how critical is the importance of the balance, technical versus creativity, technical knowledge versus creativity, and I mean, obviously engineering is a creative skill. It's not often looked upon like that. It's not like an art, if you will, in the traditional sense. But how do you? I know it's important, but how do you kind of support balancing that?
Yeah, I kind of take the game that I'm going to let the college teach the technical skills.
Okay.
And I'll teach some, obviously, but I think my job is the creativity, is to get the kids excited and to get them thinking differently and thinking like engineers, thinking with empathy. We talk about this all the time, but it's not what you want. It's what the customer wants. And you think you can create what you want, but the reality is if they don't want it, and then some kid always says the Steve Jobs thing of like, we have to tell them what they want, but quiet.
Every time with the Steve Jobs.
From the book of Jobs, I present.
Right. Yeah, there's always that one kid who quotes that line that he said, but take that aside. The idea is, hey, let's build something, let's touch something, let's see what happens. I mean, I think that's been a theme here, is this idea of allowing kids to exhibit the creativity and develop that creativity. And then, you know what? Yeah, we're going to do some simple machine calculations and ideal mechanical advantage and stuff. But at the same time, we're not going to get deep into the math, because I'll lose the kids that way.
Yeah.
Go back to that ring and disc example I gave in AP Physics. I could easily tell them, here's the math, here's why, but they've got to play around. They've got to make mistakes. And I think it's the job of the teacher to balance that curriculum, that technical, with the creativity. But I think kids need the creativity. I think every job, whatever job that's paying halfway decent amount of money, needs creativity. A lawyer, a automation expert, whatever you want. I mean, you could rattle them off. If you're not being creative in your work, you're not advancing. You're not doing anything of, I think, substantial value. And I think that's our job. I think it's to provide kids experiences where we do use some of the content, some of the curriculum, some of the technical but really let's develop that creativity to send them off to the college and then say, hey, advanced, higher, smarter people than myself, you get the technical skills in the kids now and in the students and move from there.
And do you have some, things you do to kind of help kids embrace failure and take risk, as part of that process to kind of, and sometimes that's just stepping out of their comfort zone. I'm in sales, right? I started out in engineering, went into sales. That was a huge step out of my comfort zone. But once you're in it, right? And sales almost becomes yet another engineering skill in and of itself. But are there things you do to kind of help, kids take that leap? Because for me, that would have been, I think, huge coming into college. I learned to do it in college, but beforehand would have been big. Yeah.
I think the biggest thing is you break it up into small chunks, and what's the silly saying? How do you eat an elephant? One bite at a time, kind of thing. And I think giving kids small daily challenges. Okay, we're going to just figure this out today, or just mess around with this. Even in big projects. I say all the time, I have these little sayings, but one of them is, you don't build a car to test the brakes. And so when the kids look at you and you build the brakes, let's test the brakes. Let's make sure the brakes are working before we build this entire car to find out that the brakes don't work or whatever the case is. And I think by doing those small, let's just start somewhere, guys. Put this together. Let's see what happens. That gets the kids to start the wheels turning and start the creative process rather than giving them this huge undertaking and saying, where do we even begin? Because so many kids, to go back to the grade conversation, they want to do it right from the get-go.
The end point. They want to.
You've been programmed to get the A, and I've got to do it right. And changing that mentality from, let's just get something. Let's get a working prototype. That's another big philosophy is again, the fail fast philosophy. Kind of a lean idea. Hey, just get something working ASAP, and then we'll talk about it. My fourth year class, I keep saying an ugly working prototype is better than a pretty not working prototype. And that's the kids don't,
or a half finished one.
I have a team that's trying to build a self-closing softball mitt. And it would catch a ball, and the empathy is a kid who doesn't have the hand strength. You can just put it on your hand, and basically you can play catch. It would close automatically. The glove is ugly, but it's working. It's closing.
It works.
You know what I mean? And it's a team of all females, and not to speak in gender terms, but a lot of times you see the female students always wanting to do it right. Boys are a little bit more, and I hate to be sexist here at all. Like I'm speaking in generalities, but like the let's build it philosophy, where typically the female engineers, let's figure it out, let's do it, which I think makes them amazing engineers. But it's okay to be ugly. It's okay to have a working prototype. We can always make it look pretty. We can't always make it work. I think that's
right.
So long story, I think small chunks is the key to getting kids to start to unlock their creativity.
What I like about your answer to this one and the previous one is you are really fostering like passion, right? And I think what I've always said in my own career trajectory is I just followed my passions and it got me here, right? And I think if you, really build and foster passion for, STEM learning in the younger generations, when they do get to college, that passion will really push them to learn these complicated concepts, and then they can get technical. But you can't teach that, correctly, at least when I was growing up. Nobody really taught that. So the passion came from like within. So I love that that's kind of your goal.
Yeah, thank you. I mean, I don't know, what do they say? 4 years old, we lose our creative process, and when you start school, or 5 years old, whatever it is, the schools rip it out of kids. Yeah, we need to bring it back.
Bring it back.
We do. I mean,
bring it back.
Definitely felt ripped.
I wanted to take a step back before the kids get to you. Now, I want you to put yourself in the situation. You're in a conversation with middle school teachers, your colleagues, essentially, maybe from the same school districts. What would you say to them as far as, hey, before these kids even get to me, because you're in the secondary education level, what are the things that they should be focused on so when they get to you, when you're teaching, you now have an assessment, because you do have to take an assessment. I don't know what these kids know. I kind of have to figure this out. What is it that they can impart on those kids, so when they get to you, it's like, you guys got it. You're already here. Perfect. What would that conversation sound like?
Yeah, I think it comes back to this idea of exploratory learning. Again, go back to the science example. Stop giving kids instructions. The kids can figure things out. I mean, there's a time and a place for it, of course, but why can't we develop more? And I would encourage those middle school teachers to develop more phenomenon-based instruction, where we say, okay, here's something cool that we've seen. Let's start unpacking it. One of the things I love to do when I teach science is a driving question board. So I'll show a phenomenon and say, okay, what questions do you have? Rather than me starting as a teacher to explain why this happens. Let the kids say, okay, again, go back to my ring in the disc. Well, why? What questions do you have? What do you observe? So I think the key is get more exploratory, get back into this idea of kind of a wise freedom of play, and let the kids, of course, the bumper thing, let them play.
I like
that. Go back and forth. Man, you got to keep them, tight, especially middle school.
Yeah.
Imagine teaching middle school. Sura and my daughter both they're friends in middle school. But you can do that, and I think once you establish those cultures in your classroom, you can get some neat things. Kids like to do that stuff. They don't want to sit and be just sponges and absorb content.
Well, they don't have the capacity, right? There's a limit to how much they can absorb. And I think you touched on something that I think doesn't come out a lot. We lose play as we progress, through educational system. And I think that's one of the most significant things that I remember from like my history class. I had this amazing teacher that wouldn't just yell at you all the information you needed to memorize, because let's be frank, like history is really about memorization to get the A. The experience that you got out of just playing the part made me, remember the dates that I would have never even cared about before.
You're 100% correct. Is that experiential learning is so important for kids, and again, to engineering coursework and science coursework, I believe just lends itself so well to that too, which is great.
Yeah, no, that's. We had even in college we had some things like that where they would say, "Hey, look, we're going to go to a power plant. This today, class is canceled. Let's go to a power plant." It was like that was. I remember everything about that tour, and even almost got into the power generation industry just because of it.
Well, but if I can interrupt you here real quick, I mean,
sure.
If you ask your children what were their favorite memories of middle school, I bet you $1 million they're going to say field trips. And not because they got out of the classroom, but because they saw something that they typically don't see. And whether that's a museum, all the kids go to museums, whatever, but it's, we have this thing called the Star of India here in San Diego, and it's a big ship. And they, the kids used to have to sleep on it pre-COVID. They would bang pots and pans in the middle of the night and give them the experience of what it was like to work on this huge, wooden ship. My daughter still talks about that.
Wow.
The experience of that. So why can't we get middle schoolers to a power plant? Why can't we get them to your offices and see what it looks like to be an engineer? And it may be boring, maybe cubicles. We have a company here in Carlsbad called Viasat, a major satellite provider for military and then Wi-Fi. That campus is unbelievable. It's got beach volleyball, there's bars, there's a fuselage of an airplane for their corporate clients to experience Wi-Fi on a plane. Like when kids see that, they're like, I want to work there, like, duh, of course they do. And so maybe that tips a kid to just seeing that environment, saying, oh, maybe I want to be, a computer scientist to work on their Wi-Fi and airplane system.
Yeah.
We got to get the kids out of school. That's, I think, my point.
Good point. Field trips. Now that you mentioned that, I could probably list off every field trip we did in middle school and high school, even back to elementary school when I was living in California. And that actually brings us to another topic: is encouraging innovation in the classroom. We've talked a bit about some of the your thoughts on how to get kids to be more creative, or how to like you said, bounce off the bumpers. do you find how do you integrate hands-on experimentation into your curriculum? How do you, in terms of maybe not a field trip, but just there in the classroom? Is that half of you try to? I mean, like what percentage of your curriculum is kind of hands-on? Would you say?
I would say the overwhelming majority of my day is kids doing stuff,
Okay.
projects, whatever. Now, maybe I'm a little bit of the exception just because of the courses I teach, but I like to say I don't really teach. I'm a teacher that pulls up a chair at the table and talks to the kids. And my teaching methodology is that one-on-one questioning at the table during the course of a project. So if you were to come into my classroom, you would rarely ever see me, a figure. One of the things I love is when kids come in to give passes and they're like, where's the teacher? They don't know because there's no figure standing. Because they're constantly doing things and I'm constantly running from table to table. So, and again, I mean, you've heard me speak here. My passion is inquiry. My passion is getting the kids to do stuff. And so therefore, I believe we can develop content through those. For example, if we're doing simple machines, we'll be doing a project and I'll stop there and we'll just do a little whiteboard at the table with the kids and I'll throw a problem out while the kids are working. Oh, you have this gear. You have this gear. Well, let's compute the gear ratio together if they haven't done it correctly. Or you do those spot checks while they're inside the project. But yeah.
Okay. Do you have some highlight stories you can share as far as, aha moments you've that stand out for you in all your years of teaching? Or maybe as a whole classroom or individual, either way.
Yeah, I think, a singular moment like that probably doesn't come to mind, but if I can talk about this fourth year capstone class that I teach, I think that is what is the epitome of education nowadays. And I think if it's tough because it's seniors and they've gone through 3 years of engineering, so there's a bit of knowledge, of skill, but I don't see why it couldn't be anywhere, if we have the teachers that are willing to do it. And so basically my mission statement is to create an innovative product to a well-defined problem. And, so we start with this empathy, we start with this research, and the kids come up with something they want to solve. I mentioned a baseball mitt. The team of engineers were like, well, somebody with a physical limitation. That was what they started with. How do we do this? They thought about making something for a young man in our district who likes to play hockey. He's waist down, whatever the term is, but he can't, do anything waist down. So he's on a hockey team. Thank you. He's on a hockey team where he's got a sled and he pushes. And they were trying to create like a better stick to push, but it didn't work. And so it ended up merging into this baseball mitt, which it's not really out there. And so then through all of the learnings and stuff, they just are all we start with empathy, we look at what's out there, we create design specifications, and then from those design specifications, we start building small parts. And I think that's my big aha moment is why can't we create more projects like this? Why can't we create more activities? Let's reduce the content and why not, give the kids more skill-based learning. I think that's really important, for kids to do. And I think, I don't know, we have Sura and I have a friend at the barn that's how we know each other. He works on a board, and he was asking me about how do we get kids to do their social media for them. And I'm like, that's it. Why can't we get kids in, I don't know, whatever class we could do this to run the social media for this local barn in their community. I mean, why can't we find those things for kids? And those are the aha moments. I think we need to do that. Get more real world hands-on experiences for kids.
So I had a quick question. You talked about your capstone. That's the correct word, right? Capstone project?
Correct.
Right, your class. Is that something that you conceived of yourself and implemented in your school? Can you tell us a little bit about how that came about? Because it seems to be, very beneficial to your students.
Yeah, it's through the Project Lead the Way curriculum that I mentioned earlier, and the way they do it is it's a skeleton curriculum. Here's kind of a pathway of the design thinking process, of the engineering process, and it is my job then to kind of manipulate it to my students, to my environment, to the schedule that I have. So I can't take full credit for coming up with this, but it really is a skeleton of a curriculum. And again, empathy, we research, we look at prior products design specs, we get into stakeholder feedback, we get into then designing the product. Now we're in the testing phase of it. Again, further stakeholder feedback. And then it all culminates in February 27th, they've got to present to a panel of engineers for here's my baby. Here's what we've been working on for some feedback, evaluation, present to the community what's going on.
Mike, get us on that panel.
Yes.
You guys, it's H Creek High School, 5 o'clock.
But that's great. Like something that is there for you to actually like fully vet and run. Even if it wasn't your own idea, that's amazing what you've done with it, right? And I think that's something that I haven't seen before.
Yeah, even AP, Advanced Placement, has created a new course called AP Seminar, where it's just a research course, and it's a similar mentality, but more of a hardcore research. You want to research more about the Holocaust? Great. The teacher's going to give you the pathway and teach you how to go research deeply into the Holocaust or whatever you're interested in. It's usually housed in a history kind of class, but the idea is let the kids go explore. So, good for the Advanced Placement for doing something like that too.
Mm-hmm.
That is really fantastic. That's like turning back the timeline in terms of being able to do the problem solving, all the things that were so eye-opening for me in college, in engineering school. Really didn't do it until junior year of university to have that freedom. And even then, you really had to push to say, well, I want to do this particular project. And you could sell a professor on making a project around what you wanted to do. You really had to sell it. And so for the real passionate folks, you could actually define what your project lab would be. But here, the ability to do that as part of your, critical thinking in high schools, that's awesome. That's a game changer. I'm with you. Is there more information online about kind of how to spin a program like that up in a school,
or something maybe you've written?
Go ahead.
Oh, or something you've written, yeah.
I don't have anything personally. Again, we follow the Project Lead the Way.
Okay.
I believe it's pltw.org, or just if you Google Project Lead the Way, you'd find it.
Got it.
And they've created they're a massive organization now. All the way, I think they're starting in kindergarten, where they've created it. It was just originally biomedical and engineering, and it's expanded to computer science, and then it's kind of spilled down the age spectrum into the kindergarten, and they've got middle school, elementary. It's become a really big beast, and I partly because I just don't think there's a lot out there, and so I think a lot of school districts have jumped on it to try to give these elective opportunities to children, because it does. I'm a perfect example, and the kids make fun of me all the time. I mean, I have a degree in biology. They're like, "Why do you teach engineering, Mr. Fieberg?" I've taught physics, and when we first started this, my mechanical engineering course that I teach is just basic physics, simple machines, circuits, centroids, some structures, trusses. It's just physics. And so I convinced my principal at the time and said, "Hey, I love to build stuff. Let me do this. Let me have an at it, even though I'm not an engineer. I'm technically supposed to. My district signs a waiver that allows me to teach this course. Every year we have to do it. Every year I'm nervous. My district is going to come back and say, no, we want an actual engineer to teach these courses. Luckily, they value me and what I provide.
That's great.
But we need, and California is very unique. We are in a state here really pumping money into career technical education. And in doing that, they want career engineers, business people, photographers, to welders, whatever, to bring their expertise into the high school and teach, to the point where you don't even need a teaching credential. I could go get my CTE credential, but you need 2,000 hours of actual work experience. And I've only ever been a teacher since graduating college. So I have a colleague who was an architect for years, and so he is our kind of liaison. So when we fill out grants, we always put his name as the career technical guy. But, so
perfect.
He teaches our design. Yeah, schools bend the rules again. Hopefully nobody's listening to this, but or hopefully many people are listening. Sorry, hopefully many people are listening.
You probably have a student revolt on your hand if they didn't sign your waiver every year.
Oh yeah.
You know what? Yeah, thankfully, yeah. I have a very supportive administrative team, so let's say that.
And results, like you've showed that you have accomplished what you set out to accomplish by inspiring these kids. So I think that really speaks for itself too.
Yeah, they love the program, and it's we've created something great. So I'm proud to be the teacher of it, and I enjoy teaching it tremendously.
And it's an opportunity, sort of leading into another area of conversation. It's an opportunity to what we were talking about earlier. You're bringing students into the space where they could be working in the future, right? You're getting closer to that place. And we were talking about competitions earlier. We've got, of course, First Robotics. You mentioned you had a few some first teams there at your school. And extracurricular activities like that. But I had another question about things like maker spaces. Do you have any partnerships with the local maker spaces and bringing kids in there to create things as well, or a place to maybe you spend some time on the weekend if they're really interested in a project they're working on at school, they can go work on it with the tools available outside of the walls of your high school?
So surprisingly, we don't. Qualcomm has a makerspace that they allow students and robotics teams to come use, which is down in Central San Diego. But for the most part, we house everything in our campus, or kids just do it. So many of these kids have 3D printers right now that they just print stuff on their own. Excuse me, I have a laser cutter. I'm laser cutting plexiglass all the time for the robot walls and stuff like that. We have a lot of tools within our robotics room, and then also in my makerspace, which I have. But no, I wish. I say to the kids all the time, we've got to make more partnerships. I think it'd be great if we could get out into more makerspace. Viasat has one too. Some kids work there for Science Olympiad. They house our Science Olympiad program. But no, I think that's another area of growth that we could do, is create more of that, so that teams, extracurriculars could go there and create. I think the reality is, I don't think they're that expensive. And I think if schools just put a little priority financially to it, you could get basic tools. You can get 3D printers, laser cutters, CNCs. A lot of that stuff isn't that expensive. I think a lot of businesses would donate to it.
Donate it, absolutely. Yeah. We donate things.
Printers coming. Mm-hmm.
Yep, for sure.
From business, yeah. So it's, I think we just have to ask. We've got to have an educator, an administration that wants to go out and say, hey, this is a priority, and let's put some resources behind it.
Mm-hmm. Yeah, so many companies, including mine, and I'm very proud of the fact that we have a program for connecting with the community, and that's just how employees do it. Things like I'm doing. We have other employees doing volunteer efforts, but also volunteering resources, capabilities. It's not just money, right? It's tools and things like that. And companies all the time have a tremendous amount of equipment that gets cycled through, especially working at the highest levels of R&D. Equipment just gets obsolete, but it's perfectly fine for a lot of applications. It's like what's that? I can't remember the name of that mill that just won't go away. There's a Bridgeport mill. You can find a Bridgeport mill. It's like, that is the most timeless thing, but you can do so many things with it in the end. And
I would actually say your intellectual property, if that's the right word for it, is more important than the physical property. Having mentors, like I said, in this fourth year class, I require the kids, once every 2 weeks to sit down with a mentor and just have another pair of eyes and ears on their project. And I send them an email at the beginning and say, hey, just ask questions, provide technical feedback, give them what you would do as an engineer or a project manager in this situation. And that has been the game changer in that course. I did it mainly because I couldn't get to everybody. There were so many groups and one of me, and I've got the kids for 70 minutes every day. And it's, most of the time I'm outside making sure nobody's cutting their hand off with a table saw or something like that.
Yes.
To the point where
there is that.
I can't sit down and be the project manager or a technical expertise. And I think, companies like you all, you need to be in schools. You need to be connecting. And that requires teachers to create projects, as we've been talking about, where your expertise, your intellectual, knowledge would be beneficial to students. And I think that's something I'm wanting to grow more and more I am sure the four of you know more, you're amazing people. You could easily come in and impart so much wisdom on the kids, and they would just eat it up to listen to your experiences, to have you part of the process. I think that is going to be another massive shift in education. Is we've got to bring the community in. It's needed. We cannot be separate. That's my soapbox.
I think he's telling
That's
you
your
that.
sales pitch.
Well, there's a lot of folks out there ready to help, ready to support.
Well, it is. And like you said, Mike, the companies again, this Viasat, which is real close to our school, they want they volunteer for Science Olympiad, for our robotics team. And that's this much work for them. They could do so much more, and their companies want them. We just don't have the ability to take them in.
Yeah.
And I think that's to echo what you said. We don't I've been in biotech, biopharma for like 22 years, and now I'm on the vendor side. We don't ever get that from schools. They don't reach out asking for those kinds of opportunities. And I think if they did, we would allocate some resources to that, because I think that is important to give back to the community, and every company wants to be seen to give back to the community.
Selfishly, I would imagine for the future workforce, and I think that's why this company Viasat does this, is that these are the kids that are going to be applying for jobs in 4 and 5 years. Yeah. How else you've got to get talent? Where else are you going to find the talent?
Sure. Your workforce, it's right there in the schools. But I think a big point you're trying to make there, Sura, and I'll speak for James. They don't have time. He just said that he's trying to watch a kid not cut his arm off in a table saw and doing this over there. When do they have time? They just don't. And you can't expect a principal to make those connections. It has to come from the local teacher level, unfortunately.
But it almost seems like there has to be some sort of shift in the way that they structure their staff, so that they have someone doing that kind of
dedicated,
outreach,
really looking for that. It's a lot of it's resources, I would imagine, right? It's a busy role. I mean,
because we have that, for example, at UCSD, right? They do the bioengineering breakfast, and a bunch of industry professionals, including myself, go and meet these up and coming engineering students and connect with them. So I think it's just the difference between funding and where it goes at that level, and funding where it goes in college level. Sorry to cut you off, Mike.
No worries. Well, we're as in our last segment, right? We're preparing for the future ultimately, and then maybe that's something to focus on in the future for schools to be able to connect with more companies and tap into those. And there's a lot of resources on the table from company to company, especially the larger companies. They have huge community outreach programs, and education is a big part of that. And it's since I work for a robotics company, I think there's a lot of our team that have kids, right, that are going through programs, and they're like, hey, we'll bring them into the office, right? They can see how, a very, very complicated robot is to make, like a vacuum robot. It has to operate in a vacuum. You have no way to transfer heat. How do you deal with that, right? There's all these things and problems we have to solve as a manufacturer that, they look at it, it's like space age. It looks like something that should be in space, right? At least that's the feedback we get. And we get a lot. It's a lot of fun for us to talk about those things. So, and it's got me thinking on also maybe more ways we can kind of reach out to different schools to be able to support and let them know, hey, we're here. We can help however we can.
I think the other thing is not just even in an engineering space, but the gamut of careers. I mean, think about how many people work for your company, and are technical accountants. They're as technical as we you engineers are. It's different, obviously, but okay, so the kid's really interested in math. Well, is accounting a career for them? What if we got accountants in schools, in the math classes, for example, and said, okay, well, here's what we're doing in my company, or here's even a challenge that I faced as an accountant. How would you figure this out, kids? That's another thing I wish we could do is, I do this course where the kids develop their problems. I would love for industry to come back and say, here's something we had trouble with. Let your kids have at it. How cool is that? And I think that's something that we could, again, to that partnership.
Yeah.
Give us a challenge. We'll let our kids have at it.
Hearing someone who's passionate about what they do, for a living and also for a career is a powerful message, right? They've wrapped their head around what they like to do and they do it for a living. That's a framework. That's a story that can only be told by somebody who does that, and it's a great experience to hear that. So go ahead, sir.
I had a quick question. You talked about mentorship and how you're mentoring these students, how you're getting others like with qualifications and expertise to also provide mentorship. Do you offer opportunities for your students to mentor, those in lower grades or those of, like coming from not such a prestigious school where the opportunities abound? Because Carlsbad is doing great, right? But there's like, how do you get kids that aren't in that system with all these opportunities excited about engineering?
I think that's a growth area totally. And I think one of the things we do a little bit, after my AP physics, we try to get some kids into the elementary schools to do science experiments just because, elementary teachers don't always have time to do science experiments. And so that's been a fun little project after the AP test. Sometimes we'll get kids to say, hey, let's build this fun thing and get the kids excited about science. But we could do way more. And I think community outreach is an area of growth for a lot of kids that would even look great on a college application. What things are you doing to help grow maybe some kids that aren't as fortunate as you are in the city of Carlsbad, for example, or wherever you may be. And so, sir, I think that's a really important thing that we need to focus on too, is more of connecting community. I do think even the robotics programs help. You see a lot of helping in the robotics programs too. Mike, I would imagine you probably see the gamut of teams and funding. Oh yeah, because funding is very important in FIRST Robotics. And if you don't have it, you're definitely left behind. And how do the resources get a little more evenly distributed? Also, so great points, Rob.
Yeah, and it's really been an adaptation process for FIRST. In the early days of FIRST, when it was founded, it was just big robots, and you needed a whole high school, a whole crew. I mean, I remember a team from Canada had 2 busloads of students for one team. And but that's a lot of resources and a lot of expense, and they, the teams would operate, but it's one robot that's competing, and there's maybe 50 kids. Upwards of. And then they developed the FTC program, which I've mainly been involved with, which is between 5 and 10 per, and maybe a couple $1,000s to found the team and even get a set of supplies to start with. Huge difference. And the Gene Haas Foundation has been a big helper in that. They're able to you're able to apply for funding, get some funding to start the teams. And I think it's why you see 28,000 teams in FIRST Tech Challenge versus, the FRC, way fewer teams. They've been around a lot longer, but you need a whole high school to support it. There's some of these teams are, middle school, you can, even in 8th grade, they can do it. Mm-hmm. And a single high school could easily have 5 or 6 teams without much of a problem. And you also have the opportunity to get more hands-on. So I think, FIRST has done a good job of sort of adapting. So not all the way down with the Legos, which is more elementary and middle school. And then, because the Legos are, in fact, I think the Lego challenges are harder in some ways because right. you have to do that completely autonomously. But then you get to the FIRST Tech Challenges, I think it's the happy medium, and the other organizations I think are following suit, being able to offer something that's more accessible and something you can fund. But for a regular FRC team, that's like a $30,000 to $50,000, at least to support that. Yeah.
But we'll link that in the description. We'll link the Pathway program, the FRST, and then the foundation that Mike mentioned. Mm-hmm.
Fantastic. Well, any key takeaways? I thought, we normally do a pick of the week.
But we didn't warn you.
Well, we didn't warn you. We didn't warn you.
Do you have one?
What am I picking for the week?
So, well, we've done books, we've done gadgets, we've done even just
These two guys always have something cool.
I don't have anything this week. So.
I do.
See?
I'd love to hear it.
Well,
go for it, Jeff.
First right of refusal, James. If you don't have anything, I can go ahead. So this past week, let me backstory this. I had filled out paperwork when I worked at Corteva after I had left, and it was to be put on patent. And I filled it out. I'm like, okay, here. The guy I worked with, who was a scientist there and still is, asked me to fill out the paperwork. I sent it back. Okay, no problem. I didn't hear anything about it. I just figured, okay, well, I don't know if it was ever issued or whatever. So I get something in the mail this week that was something about, congratulations on your patent. Would you like to create an award where you can put it in there and frame it, blah, blah, blah. I'm like, what is this? And they told me the patent number.
Public record.
Like, wait, they know it, but I don't.
They know it.
I'm like, and then I went and looked it up, and I'm like, holy smokes, I'm on a patent. I was
patent
like,
got issued.
Yeah, my name. I mean, I'm the first one in my family to do so. It wasn't a bucket list item at all. I just one part of it, and a lot of those folks on that list I worked with previously, not at Corteva, but at a company that was intermediate between me and Elizabeth. But it was just kind of a shock to my system, and I'm like walking around, cool. I'm like, yes, I am a patent holder.
I have been published.
Yeah, exactly. So it's one of those things where you're just like, I can't believe this actually happened to me. So that's my pick of the week.
Congratulations.
Congrats, Jeff.
It's all related to rodents and bugs. So.
And to all students out there, you don't have to work at a company to get a patent. That's right. You can always go out and get yourself a patent. But that's cool.
Well, that's super cool, Jeff. Congrats.
Thank you.
Well, while James is thinking about what his pick of the week is, I've been playing around with organic chemistry lately. And so I just wanted to plug like model kits as a way to think in 3D, right? We talk about like bonds between carbons and oxygens, and you don't actually see how that impacts structure until you build it. So I'll link to this kit, but I think it's really great to enhance your learning of science by building these models.
More importantly, did you pass your test during SLAS week?
A+, baby.
There you go. Good job.
Awesome.
I was so stressed out.
This is organic chemistry?
And her doing the test, it was like,
Yeah.
Multitasking.
So there's multitasking and continuing education.
And learning Mandarin.
And learning Mandarin as well.
Wow.
I'm taking up Chinese or Japanese, sorry.
Ooh, nice.
After my experience with Yokogawa, I was inspired. They are very honorable and humble people, and I got chills. I'm still getting them today when I talk about that experience. They're just humble people, great to work with.
This is Conversations in SLAS?
Yes. Oh. Yeah.
And SLAS is a perfect place to make these connections, and they are, building education as part of their, targeting specific groups of students and, bringing students from colleges. But I think also being engaged with community and high schools and programs like this, it's something that it's very important for the society that it brings kids to see the actual applications where the robots are being used and devices, that technology that is being built. And the Laboratory Robotics Interest Group also, they have a goal of giving back to the community. So I would suggest as well to connect with them, because some chapters that are larger than others are able to, make donations. Or I know New England is, for example, giving scholarships to kids in schools, and it's part of their program as well.
Awesome. We should link all that in the description.
Mm-hmm. Yep.
Did you think of anything yet, James?
The only thing that's coming to mind just on this theme is I read a great book called The Lean Startup, and I'm blanking on who the author is right now.
That's a good book.
Yeah. Okay. So, and again, just the idea of if there is an educator out there, while it is more geared towards the engineering world, I think the philosophy behind that, getting a working prototype as fast as possible, is the most important thing. And I think that's kind of the central theme of the book. But definitely something that could be related to any educator out there to try to bring that idea, that mentality into their practice. And I enjoyed that book a lot.
Eric Rees, was it?
Yeah.
I think that's right. Yeah.
Okay.
That sounds right.
Added to my Audible queue.
Yep.
All right.
See, you got one. Awesome.
Yeah, the books are the best, actually. I sort of started the trend with doing a book for pick of the week, and that's it was so. Jeff and I in the past have done some technology, even as we improved our podcasting rigs and whatnot. But Elizabeth. Any pick of the week?
No, I don't have one this time.
We need to buy something for Elizabeth and send it to her so she can play it.
Yes, I'll give you my address. No, I'm just kidding.
Well, James, really, really inspiring conversation and just a powerful message you have. And I think it's something we're really glad to have you on, and our listeners can hear that. One of my favorite things you said was sort of, bouncing off the bumpers as a way to, in encouraging critical thinking, just resonated so much in the discussion. And, I think any key areas of resonance, Sura, Elizabeth, Jeff?
Empathy. I think empathy. I've never heard a teacher say come from a place of empathy. That's pretty good.
Yeah. And I think as a parent, it's this conversation was just eye-opening, and I see the gaps in the education system here, and I worry a lot about that because I see that there's no motivation that comes from the teachers. They just come and dump all the information to the kids, and they just have to learn. But finding other programs and other ways to get them motivated, I think that's what the parents have to do, and we have to be on top of that too.
Yeah, I think the letting the kids figure this out, as far as, you can fail. Failure is that first option because you have to get there to learn something. And you're not going to hit it out of the park the first time to bat in the major leagues. And then just allowing, Elizabeth, to your point, what teachers like James can do with a little bit of freedom. Let me do things a little differently, please, so we can reach these kids and we don't lose them from K to 12 and beyond, because we're trying to fill those gaps, but you got to give the teachers some freedom. So
yeah, thank you guys. I think that's so important. And then, I showed a video, I show these day in the life of an engineer videos to my sophomore class. And one of them was just a designer, and he designed the headband for the Beats by Dre headphones. I don't know what those are.
Okay.
But his point was, and this is just a simple headband.
Yeah.
He was on his 30th prototype, and
wow.
I use that more than anything with the kids. They're like, here's a guy that's working on these amazing headphones that are super popular, and he failed 29 times. And that's okay. His company still wrote him a check every week for his paycheck.
40, that's all I have to say.
At least 31, he was going to get canned. But who knows? The point is, I don't know. He failed 29 times, and that was okay. And I think that's the mentality. But he tried again. So, thank you guys for saying all that nice things.
Well, pleasure to have you on, James. And Helical Brew viewers and listeners, this is, of course, our first episode in our Blueprints to Breakthrough series with James Fieberg, STEM educator. Thank you so much for coming on. And it was a pleasure to meet you. And we're looking forward to publishing this episode on our YouTube channel as well as on Spotify and iTunes. Video available on YouTube as well as Spotify, and audio only on iTunes. www.helicalbrew.com takes you straight to our YouTube channel, and you can engage with our content there and view other episodes. But we'll try to get this episode out in the next day or two, and we will announce it when it does. So in the meantime, feel free to go to our channel, connect with us, ask questions, explore our resources, and of course, like and share our episodes and channel if you like what you're seeing. So from the Helical Brew crew, thank you very much for joining us. We'll see you next time.
Thank you for joining us on the Helical Brew. We're glad to have you with us. For more episodes, please visit our website at helicalbrew.com. That's helicalbrew.com.